From the floor of the Tijuca forest, the statue of Christ the Redeemer appears as a silent, geographic constant overlooking Rio de Janeiro. It is an active Catholic sanctuary and a symbol of Brazilian identity, so pervasive it appears on the nation's currency and official documents. To the observers below, the monument is a fixed, immovable part of the landscape, a landmark that seems to exist outside the reach of environmental decay. But the same 2,300-foot elevation that gives the statue its presence also subjects it to a uniquely hostile meteorological environment. On the summit of Mount Corcovado, the structure is frequently battered by high-altitude tropical storms and extreme sudden wind shear. The electrical threat is constant. The statue receives an average of 10 direct lightning strikes every year. The mountain summit exerts a continuous physical pressure on the structure, creating a persistent struggle against the natural elements. The specific geography that makes the statue a global landmark is the same force actively attempting to destroy it. Building a 38-meter structure on such a violent peak in the 1920s forced engineers to reconsider traditional masonry. Engineer Albert Cacot developed an internal skeleton of reinforced concrete designed specifically to withstand the intense pressures of mountaintop winds. While French sculptor Paul Landowski modeled the primary forms, Romanian artist Gheorghe Leonida was commissioned to carve the delicate features of the face. Every ton of concrete and clay had to be hauled up the incline using a small cogwheel railroad, a logistical effort that lasted nearly a decade. When the project was finalized in 1931, it stood as a triumph of international collaboration and modern engineering. But the completion of the concrete frame was only the first step. The structure required an external defense to survive its first decade. To prevent the concrete from eroding, the exterior was covered with a mosaic of 6 million individual soapstone tiles. These tiles were chosen for their durability and ease of use, serving as a weather-resistant shield for the vulnerable concrete beneath. Even with this shield, a biological threat began to emerge from the surrounding forest and the nearby ocean. Analysis of the stone reveals that wind-borne fungi and mosses thrive in this damp environment. These organisms produce mevalonic acid, a chemical byproduct that slowly degrades the soapstone over time. There is also a hidden geological danger. The mountain's rocky ground has high electrical resistance, preventing lightning currents from dissipating quickly. This forces the current to linger within the statue, causing internal pressure that shatters the stone fingers and damages the head. Traditional lightning rods used in the 20th century actually increased the risk, attracting more strikes to a frame that was already struggling to ground the current. Today, preservation is a constant scientific operation, conducted by teams working on scaffolding hundreds of feet in the air. To neutralize the biological decay, experts now treat the tiles with advanced silicone-based water repellents. This treatment reduces the stone's porosity by 93%, preventing water from reaching the interior without changing the monument's color. To manage the lightning, the old rods were replaced with the EvoDesk lightning prevention system. This system dissipates electrical charges before they can build up, essentially making the structure invisible to the lightning strikes that once targeted it. The long-term integrity of the monument now depends on these specialized chemical and electrical interventions. This landmark now serves as a site of ongoing, high-stakes material science. The environmental forces at the summit will never stop. If the maintenance and scientific monitoring were to end, the structure would rapidly begin to fail. Engineering at this scale is not a one-time achievement. It is a continuous, evolving dedication to protecting our landmarks from the inevitable decay of time.